Hello everyone, my name is Arthur Grillo, and today I'm going to talk about the status of KUnit tests on the DRM subsystem. Little disclaimer, at first, a colleague of mine was supposed to be here with me talking, Carlos, but due to personal reasons, unfortunately, he could not be here. Okay. First, a little bit about me. I was a Google Summer of Code participant this year for X.Org, that's why I'm here. And also I study computer science on the University of São Paulo. I would like to thank the X.Org Foundation, Google Summer of Code, my mentors, André Almeida, Maria Canal, and Thales, and the University of São Paulo. Now let's start with a little bit of context. What is unit testing? Basically, unit testing is when you test individually small parts of your code. Normally, you test functions. So you pass some arguments to that function and see what it returns, if it returns what you expect. The idea is pretty simple, but it can be very, very powerful because first, you can assert behavior, so you know that the function is doing what you think is doing. Also, if some bug occurs, it may fail a test, so you narrow the search area, you know that it's related with the function. And also, if someone sends you a patch, if your source code with the patch starts failing some tests, you know that there is something wrong with this patch. So it's really good for automating and managing source code. So it would be really great to have that on the kernel. And we have KUnit. KUnit it's a unit test framework introduced in 2019 and is maintained by Brandon Higgins and David Go. It is inspired by other popular unit test frameworks like JUnit from Java, Python's mocking library, and also Google Tests and Google Mock from C++. It has some really nice features like assert and expect macros, parameterized test, that is test that you have one test function with different parameters, so have many test cases with just one test function. It's really great for abstracting tests. Also, some really quality of life features. It can do memory management for you, so if you allocate something inside the test, it can free for you. And also, each test is run inside a try-catch. This try-catch is implemented inside KUnit, so it's really interesting to see the source code. I did. And so it's done like that to see if some error occurs and you assert it. It will reset the context and will not affect the other tests. Now I'm going to explain a little example using KUnit. This is the simplest test that you could write. You just create a function. This function has to receive the KUnit constant as an argument. And in there, you can use the expect and assert macros however you like. Here we're testing if 1 + 1 is 2. I think that is true. I don't know. And this is a parameterized test. First, you declare a struct with how the parameters will be. This we just have an int. And after that, we create an array with the values of those parameters in each test case. After that, you do some boilerplate to make KUnit know that you have these cases and how to print them, the name of the test, each case. After that, you have the test function. It's really like the other one. The only difference is that you take the parameters from the KUnit context, and after that, you use the expect and assert macros like you use in the other test. After that, you place those two functions on a KUnit case, and this KUnit case and a KUnit suite, and it's the end. You wrote some tests, some simple tests. So after that, you want to run those tests. So you run in KUnit. You have two ways to run it. You have the KUnit tool. It's a Python script that builds the kernel and runs the kernel for you. If you don't pass any architecture arguments, it will run the UML architecture. So it will run like any other user space program. But if you pass an architecture to it, like x86, ARM, PowerPC, it will run a key movie M for you too. Or if you want to run natively, you just enable some configs and it will run at boot. Or if you enable as modular, it will run the tests when you start them. This is the output of the KUnit tool. You see that this is the output of the example. You can see that our test passed, so 1 + 1 is 2. And another great tool to have when you're doing unit testing on a kernel is gcov. Gcov is a covering test tool. It's really good to have a sense of how much your source code is tested. And it does that by watching what lines of code are ran when you run your tests. It's really great to have like, you have 60% of your code coverage, but it doesn't necessarily mean that you have good tests, because you just have to execute some lines. So you have to still pay attention of the quality of your code. This is how you run it with gcov. You just pass additional configs to the kernel to enable gcov. And after that, use lcov to collect the files that gcov generates. And after that, use genetml to generate a HTML file that you can see the cover status. You can see they highlighted the version of GC because there is a bug that you can't only run gcov with a GC version older than 7. Because after that, there is some bugs, 2 bugs I think, in GC that impossibilitates the use in the kernel. This is a no issue, and it was already discussed, but it haven't seen a fix because it's too difficult, because you have to change a lot of things in the kernel and in GC too. All of that I learned from this blog post, so if you want to know more, please go there. This is an output of gcov. And in fact, this is the output of the core functions of DRM. As you can see, we have a lot of reds, so we still have a lot of work to do. And that's what's the theme of this talk. But let's see what we have. We have some of the core files of DRM tested, not all of them. You can see some of with better coverage here on the first image. Also, we have on the TTM, one of the memory managers of DRM, and also the VC4, the video driver for the Raspberry. You can see the coverage from TTM on the second image. But I think we can do a lot more, like we have on the test on TTM, why you can't have it on Gem, the other memory manager. Also, when I sent a patch to VKMS, another thing, there was some discussion about adding unit tests to VKMS too, another driver of DRM. So we have a lot of places to add tests. We just have to do it. So we have a lot of work to do. This is what I did. I wrote some functions to the DRM rect and some tests, the tests for the functions from DRM rect and DRM format helper. The DRM rect is just some functions that operate on the DRM rect struct from DRM. And the format helper is some functions that convert from one format caller to another. The first file was a little easier because it's just some math operations, so it's a little easier. But the format helper was a little more difficult. As you can see, I didn't got it 100% of coverage because some functions needed some mocking to do because it uses I/O, and due to time, I couldn't do it. But in the end, it was still a pretty good work. We got 94% coverage, and it's on the kernel now. Also, another aspect of KUnit is that I think it's a good introduction to new developers on the kernel. Because first, we have a lot of work to do, as I demonstrated, but also the most things that I struggled when I was developing to open source, but specifically on the kernel, when I was first starting, was that I found a lot of things to do, but few of those things I think I could do, because I didn't have the knowledge to take a task like fix this thing or add this feature and subdivide it in smaller tasks and go and work on that. But unit testing is it's already a small task. So it's really good for new developers to start doing that. Also, another aspect is that when you are unit testing a subsystem, you are gaining knowledge about the subsystem. You have to know what the function does and why this function exists. So it's really good for creating knowledge from a subsystem, so the developer could do other tests on the subsystem. This is a case of study that this was a test function that I wrote. This was I think the most complex one that I wrote. This tests a function that main copies some data from one frame buffer to another. It basically does that, but it was complex because it is one of the few functions from the DRM format helper that support color formats that have more than one plane, and so it didn't exist any other test that had this support, so I had to write it. And to know about color formats, that color formats can have more planes, and how the memory displayed on the RAM, all of that I need to learn and about subsystems. So it was a great way to learn about subsystem. Also, I had some complex issues with the type of the array, because some color formats have each channel doesn't align the size of each channel. So, and little ending endians, all of that stuff, great stuff. But at the end, I got it working. You can see that I have the same case with different formats, and this format has different number of planes. And it was pretty great to do some testing on the kernel. So if you have someone that wants to start kernel developing, I think you can ask him to test some functions that you think it would be good to have some tests. And that was my talk. Some questions?
Hello. Okay. While you were writing the test, did you encounter any bugs that were, did your test uncover bugs?
Unfortunately, no. But it would be really cool to see. But no, I didn't found. But it was really great to see like how this function really worked. And sometimes I think I thought that I had the test right, but the function is not passing because I didn't understand how the function was really working. So it was really great to have a good sense of how the function was working. But no, unfortunately no. But we don't know, like, after some time this function has a bug, so the test catch it, so yeah. Oh.
Just for like feedback, I definitely encountered some bugs so I'm the one who did the testing on the VC4 driver.
Oh.
And so, yeah.
Yeah.
I definitely did.
Yeah, so it's really great to have unit testing on the kernel. Really great to know that. So I think it's done. Thank you.